So now we will talk about dynamic friction. So the dynamic friction is the friction where always acting against the direction of the motion. So now you can see from this figure, if external force is to the right hand side on the M object, the surface is a rough surface, so then we have a coefficient of friction. So if the motion is to the right direction, always the friction force is acting against it, opposite to that. Now, what are the other forces acting on this? So we have mg and we have the normal force R. Okay. Now, considering the motion of this mass m, the motion is completely horizontal. So that will tell you there is no motion in the vertical direction. So there is a vertical equilibrium. There is a vertical equilibrium. Okay, vertical equilibrium in forces. So that will tell you R is equal to mg. So that is your first equation. Now we will understand the definition of Fr friction force. So the definition of Fr would be mu times R. So this R would be the normal force acting on M. Mu is the coefficient of friction. So now you know R would be mg. So you can replace R by mg. So it's mu mg. So that is the friction force. Now, if you need to find the acceleration of the system, what we do to find the acceleration, we will use F is equal ma to the system. There is no system, essentially just one object to the right hand side. So what is the external force? External force would be the net force. Net force would be F external minus Fr, friction force. That is equal to m times a. So from here you can get F external minus Fr would be mu times mg is equal to ma. Now you can subject a, so it would be F external divided by m minus mu g. Right, so that would be the answer to acceleration. Okay, so now we will discuss this question. So there are two masses m1 and m2. F external force is provided. It's a rough surface, mu is equal to mu 0. So there will be only one drop, so the tension would be T. So what are the forces acting on this? So there are two friction forces. I would say F1 and F2. F1 and F2. And we have R1 and here we have M1G. The normal force on M2 would be R2 and the weight would be M2G. So the motion is to the right direction. Now using vertical force equilibrium, okay, so vertical force equilibrium, what we can say, R1 is equal to M1G and R2 is equal to M2G. Now we have to find F1 and F2. Those are the friction forces. F1 force would be mu 0 times R1. That would be mu 0 M1G. That is my third equation. F2 would be mu 0 times R2. That would be M0 M2G, and that is my fourth equation. Now what we will do, we will use F is equal ma to the system in right direction so that we can find the acceleration of the system. So horizontally, the net force would be F external minus F1 minus F2, because F1 F2 are friction forces. They are always opposite to the motion, which is equal to the total mass would be m1 plus m2 a. So if you plug in the values for F1 and F2, that would be F external minus F1 would be mu 0 m1g minus mu 0 m2g is equal to m1 plus m2a. So acceleration would be, in general, mu 0 m1g minus mu 0 m2g, the whole thing divided by m1 plus m2. So this is the answer. Now when the values are given, it's just a matter of plugging the values into this equation. So I would recommend, when you do these questions, don't first play with the numbers. First use the theory, the concept, and then try to find the acceleration or whatever the necessary component from the given details, and then finally plug the values into the equation.